Okay, Team Algebra 1, this is kind of a big day because this is our last unit. Oh my gosh, do you believe it? It's true. So we are on page 90. Well, I'm not. Now I am. We're on page 90, and the title of Unit 11 are rational expressions. So we're going to first go backwards a little bit, and we're going to talk about what rational expressions are, and we're going to go back and talk about GCFs and trying to write rational expressions in a simplified fashion. So you may or may not remember from 7th grade, a rational expression is a fraction, a ratio. It's got a numerator and a denominator. So the rational expressions that we're going to mostly concern ourselves with in this unit are where the numerator and denominator are both polynomials, meaning more than one term. Monomial is one term, polynomial is two or more. So just as a little review, when we are trying to reduce fractions, we are looking for common factors. So we're going to kind of make a multiplication problem out of this numerator and denominator and see if we can cancel a common factor. So I can think of 24 as 6 times 4, and I can think of 60 as 6 times 10. And then I know anything divided by himself is 1. So this is really just another form of 1, and they will cancel. Now I'm left with 4 and 10, and I see I really haven't simplified this all the way down because I can think of 4 as the product of 2 and 2, and 5 times 2 will give you the product 10. And again, the 2's will cancel because anything divided by himself is 1, and your final answer is going to end up being 2 divided by 5. So this is nothing new. This is just a little bit of a review, but I just wanted to introduce the idea of factors canceling numerator and denominator. So in this example, if I were going to do this one like I did 24 over 60, I would rewrite 15 as 3 times 5 times y, and 25 I would rewrite as 5 times 5, and then I'd have 4 y's as factors in the denominator. And when I go to simplify, there's a clever form of 1. He's gone. Another clever form of 1, and I put it back together again, and my simplified reduced fraction would be 3 over 5y cubed. All right, so we're going to use this idea of factoring and then canceling common factors to reduce fractions that have polynomials as a numerator and denominator. First of all, we're going to look at the numerator and the denominator individually. We are going to factor the numerator completely and factor the denominator completely before we do anything to both the numerator and the denominator. And then, ultimately, after we've done all of that factoring, numerator and denominator, we're going to look and see if we have any factors that are common to both and therefore would cancel each other out, and that would help us simplify the fraction. So, before we actually get started with fractions, because none of these are fractions, obviously, but these are polynomials. All of these have more than one term, and we're going to look and see, do any of these have a factor that we can factor out? So we're looking to see, all of these have a common factor of 1. So if you think about this guy, he has a common factor of himself times 1. But we're asking, are there any other factors besides 1 that we can rewrite this expression with actually factoring that common factor out? So this guy, no, this is all we can do. 2x and 3 don't have any other common factors. 3x plus 6 do have a GCF of 3. So I can rewrite this as a product of these two factors. This is considered a factor. All inside this grouping symbol. He is a factor, and this is a factor. So this expression is made up of two factors. Example C, the GCF is x. So again, I can rewrite this as a product of two factors. There they are. This guy, you might think that you can factor him, and you might try the AC method, but nothing really works. This guy cannot factor. He does not factor. Now, you can use the quadratic formula to solve and actually get the values for x, but he does not factor. This guy does factor. He has two factors, x minus 2 and x plus 1, that when you redouble distribute, this is what you end up with. So we can write this guy as the product of two factors, and then I hope you recognize example F as the difference of two squares, which makes his factoring x plus 3 and x minus 3. So now we're going to actually deal with some fractions, a denominator and a numerator that are getting us to the point where they're going to be polynomials. So this example is kind of interesting to me. The problem is written 3 plus 12 over 3 plus 15. Now, the fraction bar is a grouping symbol. So you want to simplify the numerator, simplify the denominator. And so if we were to actually do this correctly, it would look like 15 over 18. And then we would say 15 is 3 times 5, and 18 is 3 times 6. The common factor is 3, and the simplified answer is 5 over 6. So the error that they did, they said, okay, 3 plus 12, 3 plus 5. I'm going to cancel the 3 and the 3. Seems like I ought to be able to do that. And I'm going to get 12 over 15, which reduces to 4 over 5, which is not equal to 5 over 6. So there's a problem with this guy. And the problem is you cannot cancel these 3's because they are not factors. This is not multiplication. So while the 3 is in common numerator and denominator, it can only cancel if it's a factor. So 3 is not a factor. There is no multiplication going on here. It's a term. The 3 is a term. So you can't cancel unless you have factors. So it says, how could the work above be corrected when finding these sums? You can only cancel it if you have a multiplication problem. So, you know, there's a number of different ways to make multiplication problems out of this. I don't know that I think this is really so particularly pertinent, but three, we could factor a 3 out and make that 1 plus 4. And in the denominator, 3 plus 15, again, we factor a 3 out and we make that 1 plus 5. And now the 3's will cancel because this is a multiplication problem. This 3 is a factor to this expression. And this 3 is as well. So the 3 divided by 3 gives you the ghostly 1, and you now have 1 plus 4, which is 5 over 6, which is, of course, the correct answer. So that's another way you could do it. All right, let's go to the next page. So now we're going to actually start working with some rational expressions where the numerator and the denominator, most of the time, they're polynomials. On this first one, the numerator is a binomial. But we're going to kind of just walk through the process here. I can't factor, and remember, let's go back and look at your rules really quick. To simplify a fraction, you factor the numerator completely and the denominator completely, and then look and see if you have any factors that will that are in common that you can cancel. So the 6, you can't do anything with the 6, but 2x plus 6 has a GCF of 2, and you end up with this. Now we ask ourselves, is there anything that we can do to rewrite 6 with a factor of 2? Yeah, 2 times 3 over 2 times x plus 3. The 2's will now cancel, and your answer is 3 over x plus 3. Now, once again, you cannot cancel this 3 and this 3 because this 3 is not a product. He is a term in this addition expression. All right, let's go look over here. GCF is m, so we end up with m minus 5. Numerator is m times m squared. Now we've got all factors going here. That'll cancel, and we have m minus 5 is the numerator, and m is the denominator. Once again, these m's will not cancel. Your answer is this. Let's look at example C. What do you see? I see a 5 as a common GCF for the numerator, the denominator. And now this entire factor is the same as this entire factor, and it will cancel. And you are left with the answer of 5/3. So it doesn't matter how many terms are inside your grouping symbol, as long as they are exactly the same, they will cancel. A couple more examples on this page. Actually, I'm going to go ahead and stop, and then I'll just continue this with the next video. We're kind of about 11 minutes here, and so I'll stop, and I'll see you back.